So I have this, I know Colin has a different opinion about how he likes to think about this, but I tend to think about persistence in sort of two ways. I tend to think about things that are sort of memory-like. So like a distributed memory store, because we want clustering to learn. And I think about things that are disk-like, which we define as stuff that survives bringing the whole freaking cluster down and bringing it back up again. Make sense?
At least one view.
I have a third element, which is
That's fine.
information which isn't necessarily persistent anymore. Transient information.
Okay.
Which should follow the same paradigms that we're applying.
I think this actually wanders in the direction that Colin was saying. I think Colin was basically saying you have two dimensions when you talk about this. You have local versus distributed. And you have temporal. I think he has a better word for it. Ephemeral is a little bit of a complicated word of definition versus durable, which is stuff that sticks around. So I was kind of thinking of here in terms of distributed things. You have some distributed things that are ephemeral, they're memory-like. And you have some distributed things that, hello Colin, feel free to correct me.
Yeah, no,
Particularly, you had a better word than ephemeral.
volatile. That's the word that's opposite of durable.
Okay.
Well, right? There's volatile and non-volatile.
I know.
Sorry, you asked me for a word that was better than that. I gave you one.
I still like ephemeral better, but if folks like volatile, we'll go with volatile.
I don't care.
Will not be volatile about that. Okay. Go ahead.
The choice will not be ephemeral.
Okay.
So, stop me, Colin, because I'm trying to channel you if I go too far off the base. So we were talking about my notions of memory-like versus disk-like things, which when I was thinking about them, talking about them, I was primarily talking up on the distributed side of things, right? And that's why I tend to think about it as sort of two poles. And the point was brought up, we have some things that, who brought it up? Some things that are just transient. And that's what brought this discussion. Or that are local, rather.
There's two questions. There's, is it replicated, is it not replicated, is it durable, is it not durable? There's a couple other questions you might want to ask, but those are at least two questions that you want to ask. And that gives you at least 4 different modes for how you're going to store data.
Right.
And we have
one. Well, technically 2. Storing data in memory that is not distributed via infinite span
we have 2.
is volatile and local.
Yes. So the Java object which you declare but don't put in infinite span cache is not durable and not replicated.
Right.
There's other questions which are synchronous or asynchronous.
I see that as a mechanism of accessing the storage, but okay.
Well, but there are systems which do that well and systems that do that badly.
Sure.
So like a log, you probably, and then there's I wrote down.
But I mean, so while he's looking that up, I've been thinking in terms of memory-like versus disk-like things that are distributed, right? So basically both the volatile and the durable in the distributed sense. And one of the things that I was noticing is currently we're using infinite span for things that are volatile and distributed, things that are like distributed memory. And infinite span will allow you to use a cache store. And a cache store is basically just something that will either load in from some durable thing your cache data, or it will write it out. So you write a piece of data to what looks like memory, it gets persisted out. And there is a Cassandra cache store implementation, so that you could, in principle, change the clustering services to allow you to mark some data as being durable. You could write it in and have read and write access as if it were distributed memory, which is desirable in many ways. But it would propagate down to something where it would be loaded back in again, where it becomes durable. And the characteristics of what you're willing to tolerate in a durable store are somewhat different than the characteristics of what you're willing to tolerate in a volatile store.
So infinite span worries me. I think it's enough for now. And I don't mean to... think InfiniSpan has a consistency model
Okay.
that it implements. And I also think and despite that, I think that it is 2 orders of magnitude off of the performance. So if you're not going to have a consistency model, there are things that outperform it literally by 2 orders of magnitude.
Like what?
Cassandra.
Which is basically a durable store.
Sure, but you can use Cassandra as a sort of an in-memory key value store, shared distributed key value store, and if you do, Cassandra outperforms InfiniSpan.
So I believe that InfiniSpan does have a consistency mechanism. The trick is that we have to provide our own partition building code.
No, JGroups actually does the right thing. My understanding is that, so from the call which we had with the Red Hat people and the InfiniSpan people, my understanding is, and I don't know because I don't deeply understand JGroups, I've been told that I should trust JGroups by a variety of people, but I haven't actually gone and talked to people that have built JGroups and got an idea whether they know what they're doing. The InfiniSpan
people basically pointed to hooks to handle partition healing now. So they've got places for you to basically insert handlers.
JGroups has those features. They layer on JGroups, and it should be possible to go into InfiniSpan and hack InfiniSpan to provide the right hooks from JGroups to deal with it.
I believe they were sort of explicit about the fact that you could, in fact, they actually have the mechanisms to stick
Actually, it's not. JGroups is wide. InfiniSpan actually is like a lot of things are hidden. It's not even exposed to the definitions.
Okay.
A lot of things.
Okay.
So yeah, during spare time to make it.
So I think we could decide that we wanted to toss our eggs, keep our eggs in the InfiniSpan basket, and go in and fix InfiniSpan. And there's a lot of advantages to that, right? We have a member of our consortium who has a strongly vested interest in at least attempting to pretend that
committed resources.
So there's certain, and they're a big company. Red Hat is a big company, which means that, like, whereas Cassandra is, Facebook is also a big company, but I don't know that they're moving at the same speed and the same level of reliability that we would like, right? My guess is that Facebook's model of consistency, regardless of how much Jonathan likes it, is probably not appropriate for managing networks.
I was actually making the point that you can make certain things scale, not necessarily that you would do everything exactly like Facebook.
No, I understand, but that's sort of. So there are certain reasons why it is that InfiniSpan is good. That being, Red Hat is a member of.
As soon as we fix it.
If we fix, there are certain reasons why you might decide that you would go and try and fix InfiniSpan as opposed to throwing it out and replacing it with something else. And they're basically, Red Hat is a consortium member, so we presumably have some leverage. Red Hat is a big company that tends to think along the same lines as the consortium, other members of the consortium, which is sort of enterprisey, actually needs to work most of the time. But
the InfiniSpan people actually do make an attempt, correct me if I'm wrong, but the InfiniSpan people do make an attempt to give you mechanisms to maintain consistency. Where they fall down is in terms of partition. Yeah, partition. And whereas my understanding is, you can do things with Cassandra to try and push it with more. But
consistency is trivial if you don't have partitions. Cassandra without partitions, Cassandra and InfiniSpan provide the exact same semantics.
Okay.
Or I guess that's not quite true, but you can certainly configure them to do that. You can configure it that way because Cassandra will push it out to will actually push it to half the replica is going to read back from it. You actually then can actually order it and will actually do strong consistency in the absence of a partition. The reason people don't configure it that way is because if there is a partition, then it goes down. And you lose availability.
It's not exactly the same behavior. In Cassandra, you can build up the columns as you go on. It's a pure distributed database that can.
So schema issues aside.
Right. Okay.
But anyway, I bring this up just because I think there's a bigger discussion to have about whether we want to buy into InfiniSpan or not if we're going to talk about the stack completely.
So I think actually, here's the thing that there's some things we need to talk about. Generally.
So the other thing that you might want to add to you have 2 axes up there. The other 2 axes that I had are synchronous versus asynchronous, which I think is correct, and ordered versus unordered, which is, do you want these?
And there's one more also, distributed versus.
Well, we've actually distributed already.
Replicated versus local is one, and local is trivially ordered, but distributed ordering.
Even local doesn't have to be ordered. It depends.
Fair enough.
As soon as you go multi-threaded, whatever,
But
I know you can actually lose order even
There's
there.
order and unordered, which, like for instance, a log file you probably don't care a lot about the particular, like as long as the log messages are roughly
At least up to
place,
some level.
you probably don't really care so much about its ordering. But for instance, so one of the things that I'm thinking about when I was trying to go through this was. Okay, I think most people would say that the actual set of flow mons installed in a given switch is something that doesn't need to be written to disk continuously, right? Like that's an ephemeral piece of state. It's about the current network configuration, the current hosts. But at the same time, if something goes wrong in your network and it generates an event, you'd really damn well like to know what the state and all of your switches were when that thing went wrong. And by the time you're going to come back and look at that, probably that state is going to be different. And so it'd be great.
Troubleshooting the operating.
Yeah. So that doesn't need to.
Eventually about recovery. In some sense, that's not actually troubleshooting.
Yeah.
It's not only troubleshooting. Let's say that
There's lots of reasons why you might.
you want right application for analytics.
You might read that.
For analytics, you need to have exactly when it happened, in what order it happened.
Yeah.
Otherwise, your algorithm.
So I mean, my motivating example is troubleshooting, which is like if I basically have a log that goes to a network administrator, an event that goes to an administrator that says like somehow a packet from VLAN 14 ended up on a side of the network where it should not have ever been. And I need to answer why. It's impossible for me to answer why without also having been handed all of the current flow program. It's very, 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 very difficult for me to be able to answer that question as to why, unless I have the flow mods that were in the switches at that point in time. If I had the flow, what?
So pretty big. There are a couple of other dimensions to small actually that I'd like to raise as well. One is basically clear layering separation, right? Which is to say, we like to have a service that you can make some decisions subsequently about swapping out the data store, if that's appropriate to your behavior. I don't want to weld yourself to a data store. And if you wind up with a data store where you have separation of some of the durability versus volatility behavior, you'd like to make sure that you have the capacity to make different decisions. So for example, if you decide that we're going to say with InfiniSpan, I think it is a useful thing, or something like InfiniSpan that handles the volatile piece, it is a useful thing to be able to have layer separation of the piece that handles the durable piece, so that you can actually make decisions there. The other dimension that I think is actually important is we have to keep in mind ease of default deployability pattern. Because it's very, very easy to start saying things like, go install Cassandra, go install this, go install that. And I think that's an overcomeable thing in some of these cases. For example, I've seen people embed Cassandra, and so it's possible that we can make a code but also a Cassandra.
So let me tell you what you've got something which is actionable, we can actually write code about. Sort of what I've been tossing around, and certainly you can tell me I'm crazy. But essentially, InfiniSpan, I dislike InfiniSpan, but it's fine. In practice, in most circumstances, I think it is strongly consistent in the absence of partitions, and eventually consistent in the presence of partitions, and that's good enough for a first release. We can basically say, look, we're going to put your controllers in a well-connected rack to each other, and you're just going to say partitions don't happen. And when they do, you're going to tolerate the pain that comes out of it. That's fine. So InfiniSpan is fine. And I think actually the other axis, what InfiniSpan gives us is replicated volatile. And I think actually that's good enough for most of what we need to do. The thing which we're missing something which is durable, replicated, and I think and it probably should be synchronous and ordered, which is like something that is for essentially for writing out config.
Config and certain data that has config characters.
But I know majority of services that we need are ordered. Let's get it. I know probably some could be unordered. Majority of our storages will be ordered.
We high ordering in our current. Well, we don't really. The only way we provide ordering at an application level in InfiniSpan. InfiniSpan doesn't order events that happen in InfiniSpan. I mean, it does, but we don't need that. We do the only place where we want ordering is we actually create keys that are the ordering, and then we sort by the keys, and then we.
So you just put timestamp or whatever, if it's time ordered or it's.
So I think we really need right now, and this is sort of where I got to when I was talking about the 4 things. I think there's this gives us theoretically like 16 possible choices. I think in actuality there's 4 things that we actually care about. There's sort of local state replicated. There's local things that are replicated which we already have as just job objects. There's the state which we want to replicate across the controller, but we don't necessarily need to persist. That's a FinSpan, and it sort of works fine right now. We'll solve that problem later.
Can you guys hear me on the? Do we have folks on the WebEx? Let's see. We only have Peter on the WebEx right now. Peter, can you hear me, Peter?
I think I hear you.
Okay, good.
So the other, so we have sort of FinSpan stuff, which is like state you want to replicate. We have config-ish stuff, which is stuff we want to persist, but probably not that much of it, right? It doesn't, right? Basically.
So if we're gonna actually, do we have the list? Yeah. Gal, how much do we need to persist? Because you guys come to mind as people who may have a lot of stuff you may want to persist durably.
Well, we're talking about big systems, highly distributed systems, not single cluster.
Right, you're talking about having data distributed across multiple logical controllers.
Within a single
logical controller, yes.
Well, we're not talking about a single one. We're talking about big distribution which can reach up to 100 million entries.
Right. So the question that we're trying to get at with you is, because I think you may be the long pole on this, right? Is in a given logical controller, right? So
how often, how much how much state data you expect to need to persist durably, to store durably? It's how fast.
Like
matters.
That will survive the restart of that controller.
It's not for that use. It's for the subscriber flow mapping use. I mean, it should be, if you have replications, it will survive single or even multiple.
So in your mind, it doesn't need to be durably written across every bit of the whole cluster.
Well, there is a concept where you can pay amount of memory to where you go to a vendor, you can state that you want to handle 3, 4, 5 failures. It will take you 6, 7, 8 servers if you want to handle these kind of failures, and then you don't need durability. Right? You can handle 2 or 3. So that's failures instead.
But I know it's not only list. Let's also look at the OpenFlow. What OpenFlow would need in durable, because I think that there is some commonality.
I actually don't expect OpenFlow to be durable.
OpenFlow. I mean, the only thing which OpenFlow wants to do durable stuff for, in my experience, and this matters, but probably not in the first release, is things like I was talking about, which is debugging after the fact, which I think would be an incredibly useful feature for us to add.
It depends how many nodes you support.
Alex, even in the case where we have 10,000 nodes and we have a trillion flows, if the controller goes down, when it comes back up, it has to suck.
Yeah, but there is related information. There's related information that I think does need to be durable, because some of that OpenFlow state data, which I agree is volatile, may be the derived result of policy data that you have actually.
Absolutely.
Yeah. So going back to the
there's no way. At least in the current information, there is no way to get around.
You're talking about fast recovery.
There's no way to get around the recovery problem. You have to read data out of the switch, and reading data out of the switch takes, in my experience, the same time as it takes to write it all out. So the result is, if you believe computing those values is on the same order of magnitude as writing them to the thing, which I think I do. Like, I mean, it's not, like, it's a small thing as compared to how long it takes to write it out. Reading and writing is the same speed. At that point, you might as well just tell the switch, throw everything away, I'm going to write back out the correct state, or write it out, unless you really want to not interrupt the current.
The problem with that is the fact that you don't necessarily know what the correct state is, because you have policies, but you don't have a backlog of everything that you apply those policies to.
So we might. Okay, so let me just toss out like what it is that I built in the past, right? Sort of. So you have you have the rules that are installed are usually a function of the topology and the set of attached hosts, or maybe prefixes in your case. And the result is that if you persistently log the set of prefixes or hosts and the policy about how it is that you're interconnecting those, you have to discover the topology when you come back up anyway. You maybe have hints about what about that let you probe the topology fast and bring up at least the part of the topology you knew about in the past more quickly than you bring up the rest of it. And maybe that's useful. But you have to discover the topology anyway. So at that point, you now have the topology, you have the policy, and you have the list of hosts that you had before. And that pretty much uniquely determines the flows you're going to go to install.
The only concern for me is, let's say I'm running a network with OpenFlow, and then I say, okay, I've got 10,000 nodes and node links or connects. My controller goes down. I have the choice of nuking the network and allowing it to reconfigure itself, which pretty much means that everyone using that network is going to be grumpy.
Yeah.
Right?
So you'd rather
for that.
Well, even with the good default behavior, the fact is that those behaviors have been put in place over a period of time, and you have to ramp it straight back up. So you don't really want to nuke the network because it's at least operating.
Fair enough.
The packets are still flowing. I don't know what your rule of thumb is, but our rule of thumb is the damn packets flow.
Yeah, exactly. And
So instead, if you had a copy of, so you could still compute the set of flows that you think you would install.
Wait,
and then
You can.
yeah, I mean, if it's not, it might not be convergent, which says that you replay the policy on the same thing, it might not produce the same result.
You're talking about making some abstractions, though, and if you're, is there a one-to-one mapping that you can get back from?
Where rather than fixing the architecture for this problem, we need to make sure we leave adequate architectural space, right? This is a hard problem. It may not be a problem that we solve in the first release, but we want to make sure that the way we put together the first release leaves sufficient architectural space. And I think one of the things we can agree about is that a certain amount of durable data is required, particularly some policy data, in order to have any hope of doing the right thing in this space.
I can also understand writing a snapshot out of things periodically. You don't need to have every incremental update logged, but you probably do want to have, once a second or once every 5 seconds or maybe once a minute is good enough of here is a complete copy of what it is that I thought the state of the network was at time t. And here's a complete state of what I thought the network was at time t plus 1. And that seems useful, but I don't think that you necessarily need that to perform at the same rate which you're going to update the flow mods that you leave on the network. If that was the case, that would be
it depends. In the databases, when you look in the big databases, frequent commit doesn't really fly. You can do commit periodically as soon as period is not large enough. Even every minute, probably commit in the database is pretty significant effect. And that's what you're saying. Let's do commit every X period of time, right? It's expensive. Commit is very expensive procedure.
Well, but in this case, you're not. I'm not locking anything when I do the commit. The reason commit is expensive is because everybody else has to pay the cost for my commit. In this case, not everybody has to pay the cost for my commit because it's relatively straightforward for me to basically say, I'm passing you. I guess you have to do some kind of copy on write.
No, because I know you cannot commit each data separately. Commit is the whole database.
Yeah.
And now this database is changing. So if you committed these two fields and this related change, you cannot commit the entire set.
Let me back
it's atomic.
Let me back up on this. I think we're getting a little bit rattled. I think we all agree that there's some need for durable data. What I'm hearing is that there is a complicated problem around recovery if the whole cluster goes down unexpectedly. And that complicated problem is probably not something we're going to solve in the first release because it's a really, really complicated problem. That clearly we need to have some level of durability in order to have a space to solve that problem. But I would say if it turns out our durability needs are much greater in scale than what they would be in the first release, that the way that we protect ourselves against that is by having the kind of layering I was discussing here to allow us to swap out the mechanism that we use for that persistent start. And so what I'm not hearing from anybody...
The question if you want to swap out or add, and the question do we have enough mechanisms to add? Let's say, let's say that InfiniSpan is okay for volatile, it's good, and we want to keep it, but we want to add something else for durable.
So what you're really getting to is being able to have a data store at the top, a data store proxy essentially, which is effectively what clustering service as simple is. It's a data store proxy. Yeah. Once you have a data store proxy at that level, you can proxy out to one thing, you can proxy out to multiple things, you can do all kinds of interesting and fancy logic around.
So if application requesting storage services and says, I want for that to be durable at that point of time, you fork it. And says, okay, fine, now I have capability to...
That is what you're option. So I think the fundamental point we're coming to is that independent of, for the choices we've looked at in detail, whatever combination we pick, we want to have a data storage proxy, which allows us to make different decisions on the covers.
Yes, and I might also argue that you probably want actually something that sits on top of it and gives you things.
You'd like to proxy the proxy?
Wait, so I think that there's value in naming things because it gives naming things differently, different expectations. So if everything looks like an InfiniSpan, okay, but everything looks like an InfiniSpan cache, you're going to use the wrong thing in the wrong ways. So if something provides roughly the semantics of a log, it's probably useful to call it a log. If it provides roughly the semantics of, commit data store, like a config, you probably want to call it config. They could map down onto the same thing.
But are those below or above the proxy?
You could put them above the proxy if you wanted to. I think that's fine.
I would think if you were going to provide different semantics, you would want to put them above the proxy. But here's the thing that my sense of that goes like this, right? Which is, it's Knuth's maxim, basically. Premature optimization is the root of all confusion.
There are very here's the axiom.
I'm somewhere we call in there about that.
Here's the axiom that I use in space, which is if you make two things that have wildly different semantics and wildly different performance characteristics look the same, you are guaranteeing that people will use it.
So I would maintain that
so if you provide one thing which when I do a write, it blocks and it doesn't come back for for a second, and you have another thing which when I write to it, actually not only does it come back instantaneously, but it also replicates to every other device in the network. That's very, very different objects, and you ought to call them different things.
Let's think for a moment about the semantics of what we're discussing, right? So we've already called out the logging semantics, and there's a fine tradition of logging processing, right? And we've called out the fact that we have volatile distributed and durable distributed. And clearly we want to be able to indicate that some data is durable, right? Other than marking the data as durable, do we have, that's a very clear distinction of those characteristics. And it is convenient.
But it's not, that's the problem.
It's still semantics.
There is a place in some code somewhere which the person who's currently hacking on this might or might not look, where there is a string that has a D in it. And that string, which has a D in it, means that it's durable. And it doesn't at all in any way, shape, or form imply to a programmer that's now looking at an object called, config. What's going to happen if I call config.put string? And if I call config.put string and my whole program locks up for 5 seconds versus my whole program keeps going, that is a bad abstraction if I can't tell which one is going to happen.
Yeah, but I'm not aware of anything that would have behavior like that. Even semantically, I don't know if it needs semantic.
Well, if one of them is, non-blocking InfiniSpan, which basically says, when you call put, I will do it locally as though it was a hash map, and then I will spend my time making sure that it replicates other people in the background. Versus, I'm going to actually go wait for a majority of the other machines in this cluster to write it to disk, read it back from disk, make sure it's on, do an F flush, and then tell me again. Those are the put.
Right, but the latter, I don't think anybody's actually arguing for anything that looks like the latter.
I think we need it. I think that there is data which people would like to be, at least inside of IBM, there are people that are building stuff on top of OpenDaylight that really want a method for small amounts of data periodically. Like say user goes to the web UI and types in configuration and clicks save, you really shouldn't lose that shit. That shit should really be there when you want it again.
Even if application assumes that it's already done, applications cleans that, that's it. You cannot get back out, I know if you don't read it
So
correctly.
if I go and I configure subnets for for half of my cluster, and then I yank and I click File Save, and I yank the power cord out of the back of my whole rack of machines, the semantics that most people expect is that when I plug it back in and turn it on, that should still be there. Save has a meaning.
But here's the thing: save has a meaning, but what you're discussing is actually really freaking expensive. And I speak, and I know you guys are in the situation as somebody coming from an industry that has struggled with SDN because the timescales on which we handle certain things are not the timescales that are asked for. Let me finish, okay? And the thing is, thinking at configuration by human timescales is bad. Because anything...
Except when it's configuration by humans.
No. Because when you think that way, because anything that you would want to have configured by a human, you want to have configurable by a machine. Okay? And those machines are going to want to configure things at much greater velocity than a human is capable of. And I have seen incredible amounts of evil done by presuming human speed policy provisioning.
So great.
Which is what you just advocated.
So great. The machine should occasionally call fsync the same way that the human would occasionally hit save. The machine can actually provide a lot more better semantics about when it's going to call that and why, and thus provide the right semantics to the user. But there are times when you actually need to say, I need this to be on disk.
So you're basically arguing for transactions.
For in very specific cases, for specific kinds of data, we probably do need transactions.
I'm just thinking, just memories flooding back thanks to the discussion, but there will be times when we will be requested to actually, let's say we have a network and it goes down and we just try that network and we can reconstruct it. There will be services within that network that an operator will actually want persisted as much as the conflict services. They will want to make sure that when this thing comes up, these things exist.
Yeah.
Regardless, and they will need to be persistently stored and hard processed.
So maybe I don't necessarily need for you to put it on disk now, but I need to be told when it's on disk and that it is on disk.
So one way to approach this problem, this is actually something that's moving down the pipe relatively rapidly on the hot web and south stuff, is the Java concurrent future mechanisms, which basically will give you an asynchronous handle for the behavior that's taking place that you can ask, is this done?
Yeah.
Okay. And you can even say, okay, I'm going to essentially synchronously block until it's done. But if you don't care, you can move on with your life.
Yeah, no, I think that's right. But I think that's.
And I think
if people don't think you actually need something that's written hard to disk, and you know when it's written to disk, then I think that what we have right now, all it needs is a way to resolve whose copy on disk that we currently have is the right copy on disk. Right? I mean, so right now what we have is, and Madhu says this is true, so I just trust him on it. But that basically we have this. So there's a configuration service in OpenDaylight. It is essentially a way to press. Now I understand how it works. It's essentially a way to press save, and it tells all the modules that ask to be told when the user presses save, so that way they can all go off and save their state. And so if the user goes in the UI and goes file save, it generates a config sync event, which is propagates out to all the modules that I would like to know when the user presses save, and they have the opportunity to write their state to disk. And I think we're supposed to wait until they have done it before they return. I don't actually know. I don't know if the semantics were done. They're not documented very well.
Yeah, but there are two things here in what you described. I know one thing is the save and check when it's done. The second is atomic save. How do you do atomic save? Now, because you send all those saves to 10 modules. I know 3 modules did save, 4th by that time changed something. Now when it changes totally different state. When those
we're back to transactions.
Nobody's done that. We don't have that.
So save is not atomic.
No.
It means we can save actually wrong configuration.
Yeah. And furthermore,
means you will come in totally wrong state.
And furthermore, if you do save right now, it's also all based on Java object serialization, which is to say that if you change the type of anything that happened to have been saved at all in between the run.
Don't upgrade between saves.
Yes. Well, no. Well, that's actually, if you upgrade, you have to upgrade the running thing.
I would like to point out that we have really good ways of persisting models.
So in the short run, I think that at least so speaking as somebody that's reasonably familiar with what IBM wants to do, the thing which IBM is missing from this is just a way to save a relatively small amount of data to disk in a persistent, replicated way. So that way, when you basically power cycle your cluster, you get that data back in the same way, and it's the same data you wrote out, and it's not half of the data it's not half the data now and half the data later. It's like, and that's the one piece that we're missing. And I think that we should just sit down and I think that we sit down and wrote that and decide either we want to write that in the clustering services model, which I doubt, but we could, or if we want to write that somewhere else. That's what we're actually missing. I think that the other thing which we're missing is sort of something which we'd really like to have, which is sort of a broader persistence thing. But I think that's more than we want to bite off for the next 3 months.
The thing is, these are not as separate as you're describing, right? Because at the end of the day, there's certain kinds of durable policy that are being provisioned by both man and machine, and in some cases, you're going to have large amounts of durable policy that's being provisioned.
You have to either decide that you want to provision it in an expensive way, or you don't. And right, either you wait for it or you don't.
No, but you also have to make a decision as to how you would like to deal with it. And this is where I'm using infinite span as a front of benefit, because most policy, while you may have a large volume of policy written, most policy, once you've written it, actually hangs out and does stuff for a while. And you would like to have that sitting in for purposes of access to make decisions in a way that's more or less morally the equivalent of memory. Once it's actually been persisted out, so you can get it again. I mean, there are some policies that get updated frequently, but not a whole lot. You may have a lot of policy coming in, but not a lot of change to a particular policy. And so, in those circumstances, I think it is, I have seen this movie before. The naivete of saying, I just have this small config I want to write and persist. And particularly, it's the wall when you run into SDN, because you suddenly have a large amount of policy that needs to come in quickly. And that needs to do stuff quickly. And that is not human-driven in a traditional sense. What?
You know, I agree with both of you.
Which probably means you're saying.
I mean, what Colin's talking about is, I think, where do I get my policy from? That has to be written somewhere, so I know where to get it. I mean, the other is what policy am I persisting in? What am I consuming from another source? There are different models that we have to have for how we're going to persist and protect data.
This is part of what I'm saying is when you look at models, right? When you look at the model side, you're basically interacting with models sometimes. And it may be that the characteristics of some of those models is they should be persistent with some characteristic behavior. And for others, like the model of your open flow, that's probably an ephemeral model, or sorry, a volatile model. And that, it is the wrong mental model to think I'm entering lines of config. In that situation, it's the right mental model to say that I have a model here that has to be durably persistent, or I have a model here that requires very serious transactional interaction. I would even go so far as to say one could imagine Yang extensions to mark your model to indicate which kinds of data are going.
Yeah, and that's you can almost see that, and I can almost start to see how that would work. And yes, I've done that in the past. It's a solution, and it was effective. I mean,
at that point, basically, your model is determined the nature of the data, and so in that case, you actually really do want one proxy for accessing data that, based upon the model's indication of the model's metadata about the data, handles it the right way. You don't want to have to sit here and go, oh crap, which interface do I use for this model or system?
I also see the point that needs this controller itself.
Brent, can you hear us? Oh, hang on. We're muted. Hang on. Can you hear us now, Brent? Brent, can you hear us? Hello?
Hit the mute button on that as well.
This is speaker number 2. This is number 2.
I just want to be sure that I don't join.
I'll text it real quick. But I think that's actually...
Is that? No, that's mute.
That's red?
That's red. That's mute.
That's red.
And then...
But I know usually...
Oh, wait, hang on.
No,
hello?
I tried that.
Hello? Brent?
No, I tried that. Usually I see multiple lights.
So I think the right behavior is probably to model the required persistency characteristics of the put in the model schema, the information of the persistency characteristics that would require a Yang extension, and then to have the data stores be smart enough to deal with that for the model, so that you don't have to sit here when you're trying to access something saying, oh wait, crap, do I have to use the policy API? Do I have to use the ephemeral data API?
We need to set the classes of data, and then we need to set models of systems.
Okay.
You would have cluster redundancy, but it's one of consistency, which is always fun, and you always get that one you read whatever.
So I mean, I think, yeah, I think part of what Colin was calling out is that some things are more durable than others.
And it's kind of right that when a box comes up, someone will have to have gone out to that box at some point in time and touched it. Whatever they've touched, they shouldn't have to go and do it again if it falls over and jump on it. That should be.
Okay. And all I'm saying is that someone may not be a person.
No. It can be Mr. O&M bot that runs out and does it. Yeah. We shouldn't be dependent on Mr. O&M bot being available when it fails.
Garrett Bot is a very friendly guy. So, I think there's actually, it's productive to sort of ask ourselves then, the classes of storage that we care about, right? Which, let me grab more colors of mark.
Oh, that's security when it's configured the policy and the controller reboots. They assume that the policy is still there.
Yes, policy in this form is equivalent to a configuration. Very much.
So I think we definitely have determined, I'm going to leave out local volatile just because it's trivially solved. Okay? But I think we know we care about replicated volatile. We care about replicated durable. Are there other particular types? I think we want to be able to support both synchronous and asynchronous in both cases.
That we have, but we probably need to have replicated volatile order.
Okay.
I know it may be the same red. I don't know what you put there.
But order unordered isn't a persistence model so much. It's a storage model more than persistence.
But we're talking not only persistency, so we're talking about general storage models. It doesn't have to be only persistency. So we probably need to have almost every. I don't know if we need to have much on
so one of the things I'm seeing
probably
here
everything should
is
be ordered.
One of the things I'm seeing here is I think that bear with me for a minute. I think that the things that are local volatile probably aren't things that are going to be volatile. It's going to be things like looking after your connections, for example. Right? Maybe we model that, but I would not say that's immediately true. I'm having trouble thinking of something that's going to be fascinating that's replicated. That's local and volatile.
I think if you think of local and volatile, you're going to push it to the south, which means you're probably going to have it in some way.
Well, yeah, but if you're pushing it to the south, you're probably pushing it through to replicate it.
No, but you're not going to persist, for instance. If I have an application and OpenFlow is a good example of messages coming in that you're not going to persist because all you're going to do is classify things in a separate way. And then you're going to deploy.
But the messages themselves are local volatile. Okay? They're local volatile. And I can potentially see modeling the messages, maybe, but I don't think it's a given.
No.
Okay. So, what I think we're seeing for sort of data keywords would be local replicated. If you're talking about putting keywords in the basically attributes of the model, volatile durable, and I don't know. The synchronous asynchronous in my mind has to do with the choice of access methods, and the ordered and unordered, I think you're right, has to do with storage systems. I still like ephemeral.
I'm just trying to remember what we were using because we had volatile, we didn't have durable, we had something. It doesn't have to be Ericsson.
I prefer ephemeral, but I think volatile probably.
I think durable. There are different forms of durable as well.
I think you may be right. And then you sort of get to the, you know, the difference between, there are different forms of code. There's the sort of best effort, I kind of sort of meant to write it. And there's the, no, it's already been written. But I think, so, yes?
Sorry, so I just had a conversation with Denise, which I think is, I mean, at some point you do have, I mean, so Denise is basically saying, look, this policy data can get made.
Yes, it could.
But I guess my claim is either you believe you need to be able to do a consistent snapshot write of all of your policy to disk in a way that you pull it off of disk later, or you don't believe that. And if you do believe that, and I think that we do, you need to provide a primitive to do it. And we need to build that primitive in some version now. I mean, like, and I think we do believe that there is some amount of data, possibly big data, we can work out how to do it for big data later, that we want to be able to say, save, and what save to do is to pause it, not allow anybody to write to that data object for a while.
For vacuum. Are we really arguing for database vacuum, essentially?
I mean, you need somewhat. I mean, you have some state which you want to. I'm sorry, but you have some state which you want to be able to provide the property to users that says, when the system says this to me, I know it is the case that when I pull the plug on the entire rack of machines and I plug it back in, it will come back with this stuff. I mean, there's no way to get around.
You said something quite a bit different than that, though, right? You said that you want to be able to take a consistent snapshot of the data, right? That's good.
Of some data.
Well, of some data. And here's the thing. Intrinsic in that is the notion that you have defined that you have a clear way of defining globally the notion that this is a consistent state.
Yes.
Right?
Exactly.
Yes.
Yes. And for that data set, then you need to have that.
I mean,
and the only way that I know of to be able to define the notion of a consistent state is to be able to take certain operations, group them into a transaction, and say, okay, for the current state of the system, either we have captured a transaction, either is there or it's not there.
Well, no, so this is actually there's two ways this is typically done. There's the cheating way, which is basically just to say there's a pause button that says this data structure or this set of data structures will not accept writes until I tell them they're allowed to. At which point you write it all out and then you tell them you're allowed to keep going. And either you believe you need a consistent snapshot of your data written down to disk, or you don't. But if you do, there isn't a way around that. The other way you can do that, which does work, is that you declare a time at which you want the timestamp to have been. So it's like I would like the timestamp of this data structure as of event 57, and basically everybody can keep going, but you know that basically this snapshot is not supposed to reflect anything that happened after 57.
Basically reinventing relational databases.
No, you're providing actual consistency on top of a data store.
Yeah, I think in this case we're talking about information which is not time critical when it is being entered in the system. It can take an extra second to be entered into the system. It's not going to kill anyone.
To be made durable. Yeah.
Yes.
You may need to act on it much faster than that.
Yeah.
Yeah. But when I ask you to put it on disk, it goes, and it goes not with all of this, and then with all of this at one time, and then the second half at another time, such that when you read it back in, you have to deal with the fact that it's inconsistent. You need it to be consistent.
You're basically asking for transactions. You may not
no, it doesn't have to be transaction, because I know what Colin is talking about. Let's say that there are two ways
consistent snapshots
to implement the snapshot. One way is to say stop all writes. Okay, that's one option, and then you do consistent copy, and now you're consistent.
Consistent snapshots is a different primitive than a transaction.
But you can also
How do you know what consistency means?
So a consistent snapshot, all that says, so a consistent snapshot is consistent with respect to set of events. And all you're doing is saying, if I know, as long as I have some monotonically increasing event identifier, I just declare that there's a logical time.
Yeah, but you have to understand that when you literally describe the saves half the length config, but not the other half. What you're really saying is, I have a stream of events, and I've determined that certain of those events have to come or go to Zooms. right?
You can't.
You don't have that.
I don't necessarily care that they're part of a group. What I care is that everything that was written out. So I don't necessarily need to be able to group events, but you can't even provide the property. So without a consistent snapshot, so you need a transaction to go to group events. If you don't want to group events,
I maintain that if you can't group events, that you can't actually determine meaningful consistency, and here's why. Because I have an application and I need to do A, B, C, D, and E in order to get to the finish line. And I do A, B, and C, and then you say I'm taking a consistent snapshot, I'm not taking writes. Well, so the state that you just took is not a consistent state.
No, but so that's false. So it is a different kind of consistency.
But I mean, but the consistency your application offers care about.
So you can certainly write applications that it's a log-based consistency. It's essentially saying, as long as what I don't want to be the case, and here's what I really don't want. I really don't want it to be the case that my consistent write writes down that application 1 did A and B, and then it writes down that application 2 did something because application 1 did C that I've never heard about before, and so I log the causal effects of something that I didn't log all in the same place. So basically, I get events 1 and 2, I get event 7, which was caused by event 3, but I don't get event 3 log. What I would like is for it to be causally consistent, which is to say that if I get some kind of state that was generated by some other state, that I had the state that generated it. And that is typically
an extremely weak notion of consistency, one that I don't think most application writers would necessarily recognize. That doesn't make it a useless model of consistency. I think it actually has utility, because you're basically saying that I should not I should not get the effect if I don't get the cost.
It means really time doesn't go backwards.
Yeah, right.
And it means
no time symmetry.
Yeah, it means that I get at least some causally consistent view of the data. And causal consistency is pretty typically used because it is one of the few forms of consistency which you can implement efficiently. And it does actually provide some useful properties, which is that I don't get groups of events, but I do at least know that, like, if I see an event, I can pick up from where that event left off. So if the application has some idea that it was trying to do A, B, C, D, and E, it can see whether it got A done, or B done, or C done, but it knows that sort of the state which it got back, at least if it picks up where it left off, it can keep going.
Right. So effectively, in order to actually put this together, this gets back to the point that you were making, Chris, about, you know, I can live with a second here or there between when I wrote and when it actually gets persisted. Is saying, you know, at some point in order to take my snapshot, I will start queuing up durable events that I will need to process after I'm done with my snapshot.
Yes, or you have to basically maintain copy on write effects, which is basically you say, I'm going to pause my state, I'm going to copy on write, so that way I have a snapshot in memory, which I'm not slowing anything else down much by.
Or you keep multiple copies of every entity, I know, basically with a timestamp.
Having this separation here,
you don't kill it, so you have previous state.
Because you write to your in-memory state, and then that is persisting in a more leisurely fashion out through.
Yeah, but you occasionally need to call. But I mean, there is going to be data which you're going to want to hit sync, and you're going to get, for at least some definition of consistency that you can reason about, get your data written out to disk, so that when you come back up, you can read it back in. There just isn't a way around that. You need that feature.
Yeah, you need sync.
Well, you need periodic sync, because I think what you're really talking about is avoiding the causality.
Yes, and so it turns out that we can implement causal consistency pretty easily. I don't know that we can implement transactional consistency easily. So that's causal consistency is pretty easy because you can just pause everything. And you can write it out. And that might be slow, but for at least for the short term, and we can implement a faster version of causal consistency later. Fast causal consistency is actually the distributed snapshots are actually, they're well-known techniques. There are ways to make them fast. We can deal with that later. In the short term, we can make them work.
Right.
But so what I do need, and you said partitions. The answer is that if you're in a minority partition, you can't save. Exactly. And you throw an error. But at least that's a sane thing which you can do, which you can tell. At least you don't lie. You tell the user, look, I'm sorry, you can't save this. Press this button and I will email you a copy of what you've done so far, so that way later you can merge it manually. But I can't do what you've asked me to do. There's nothing for that, right? Otherwise you would come back up in an inconsistent state, and
you can't do our apps. You can email your user if you can't do this. I mean, you can throw an exception, but
Well, I mean, presumably, so, okay, you don't want to do is throw an exception and then delete the last 10 minutes worth of config the user has done. What you want to do is you want to throw an exception. You want to say, I have stored the last 10 minutes of your config in this log file on the machine you're currently using. Which you can access in some fashion, and in order so that way I haven't destroyed your work. I've made your life more painful, but I at least haven't undone the things that you did, just as a matter of. So this is what's missing. I actually think it's the only thing that's missing right now that we really need to build real stuff today. I think there's better things that we could do, but in terms of storage, I think InfiniSpan, it has its limitations. I wish we could fix them, but I think that it's sort of okay for releasing stuff, for releasing a first version of OpenDaylight. What I think is not sort of okay for releasing a first version of OpenDaylight is not having a way to save some amount of configuration that persists across pulling the plug out of the back of the rack and plugging it back in.
One problem that I had, at least I know one of our people mentioned, that InfiniSpan is a key-based search, and not everything can be stored as a key-based search. Or at least it could be very complex to store everything as a key-based search. You need to flatten the entire network to create the keys, and that is another way that InfiniSpan could be not the best tool.
Potentially. And so the thing you get into is looking at how do you persist models, right? And I think one of the things we were talking about when we were off on Eunice is
I want to leave the models out of this discussion. I think so okay, let me put it this way. I am at best 50-50 convinced that we can ship something on models that works. And so if this conversation involves models, in my mind it's 50-50 likely to be useless. And I realize that's a bias of mine, but like I really think if it's at all possible,
we could agree on a few things.
If it's remotely possible, we ought to avoid having this involve models.
We can agree on a few things. We could agree that we need to have a data store proxy that can deal with these issues. I think we've agreed that we need to have some way of having a notion of whether a particular set of data needs to be durably persistent or not. Right? That's something that you have a preference to do it in an API sort of way. I think Chris and I had talked about it making a lot of sense to be able to build that into the model so that the user doesn't have to worry about that.
I'm not 100% sure that what Colin is talking about I would be modeling into my
config information.
Well, yeah, okay. If it's a separate, I could have a partition which is handling config policy, but I wouldn't necessarily map that to my network so much because it's more a causality rather than an actual network definition. But there are parts of my network that I may want to also flag persistence at different times. And that maybe that matches.
If models work, they are a useful way to specify how you would like your data to be persistent.
Yes.
I think that is the same which we all agree on. I guess what I don't want to do is I do not want to throw everything into the model.
And so just to be really, really clear, and I believe way more in models than you do, that I also have been very careful in structuring things like the release plan to make sure that we move in smooth incremental steps where we have not overcommitted ourselves and blown our brains out at any given point, right?
Fair enough. I mean, so I will tell you this, that anything which I'm counting on for IBM to have at the end of this release, I am not tying to models. I don't have a politer or less blunt way of saying that. I think that's, because I think that's potentially risky. And so
I would have to say it is risky because right now you don't know.
Yeah.
So
we're gonna have to explore.
So I mean,
nothing gets modeled, but that's just life.
So I think if it's actually impossible to have this discussion without models, I'm willing to talk about it with models. But if I can conceive of any way to have this discussion without models involved in it, I really want to have that.
I would say that I'm willing to move to a hybrid of that discussion, which is to say that I'm willing to move to a discussion that says we need to support models, but we need to be able to make sure that we have a story that doesn't involve models as well as a whole.
Sure.
And I think that meets your need.
Yeah, I think that sounds good. So I think that so I'm coming at this from just a functionality point of view, which is like rather than sort of a high level how are the APIs going to work and how are the layers going to work. That's well and good, and I think that's fine. But I think that at the bottom end we have a piece of functionality that we would like to do, which is sort of this consistent save. and we need to implement that and build it, and we can have a discussion. I think the more valuable discussion would be to. So there's two discussions we need to have. One of them is how should we actually implement that? Because that's actually not a trivial statement. And the second one is where do we want it to sit inside of our current service hierarchy? And I think that's a second, which is do we want it to sit underneath clustering services? I could be convinced of that if you want to. I think clustering services doesn't actually have like an fsync equivalent. Which
I think we agree that we need a data store proxy, right? And I think that one of the things we need a data store proxy. We all agree about that. That proxy has to be smart enough that it can basically proxy to potentially multiple things depending on the characteristics of the data system, right? And so what clustering services gives you is two things that are interesting. One is that it gives you an interface which allows you to make a choice of different proxy. And two is it provides the implementation of the proxy. And so I think that is a good place to start to do concrete work. Now, do you discover as you do concrete work that there are limitations? Do you possibly even discover as you do concrete work that you'd like to do something that's somewhat different? Possibly. But let's look at what a first concrete step looks like. Because what makes sense to me in terms of a first concrete step, right, is to say, okay, for a first concrete step, from a deployability point of view, we would like to have a simple deployment model. Can we get a stack like this working in a way that involves not having to tell someone to go install Cassandra in order to get it working?
So let me just toss out my strawman thing, and I'm not sure that I have time to actually go implement this, but I can at least toss it out, which is let's keep the current Java object serialization, which is ugly, but it is what it is. Basically, add a clustering services backing implementation that gives you a cache, and that cache is basically but it essentially has three extra functions. One of them is pause, one of them is write to disk, and one of them is unpause. That would at least give us, for a single key value cache, the ability to go write it out to disk consistently, and you could make sure that a majority, and you can make sure, in some ways, to make sure a majority of the people actually write that out to disk before it is that you unpause.
So I think what I hear you saying, just to make sure I understand, is that you want to have some kind of magical attribute. And I don't mean magical in this very two sense, just because I don't want to get into all of it. So when you have marked data as being unicorn data, that when you call pause, then you can call this pause on unicorn data. It doesn't affect any other kind of data. It may be, for example, volatile. That you can then cause all the unicorn data to be saved, and when it's saved, then you will unpause and continue.
Yes. Now, we need to make sure it's saved.
It's something like breakpoint in a thread, in a debugger. So you breakpoint and you know that all other threads stop because you cannot afford that other threads will change everything what you need.
So effectively what and I want to just go really carefully into this because some of what you said doesn't map entirely to my understanding or my immediate intuition about the requirements, which means there's something I need to understand more deeply. You want three things, right? Pause, save.
Save to a majority of the currently on instances.
Full save review.
Yeah, I mean, really what I want is save at this moment, this second in time. I would like a majority of the.
This is coming again because you have in my mind you've taken two things that in my mind doesn't get right are bettable under the notion of save.
Yes.
And you've made them external. And what I think is what you want to save. Sure. Such that you get the snapshot and save. So what you want to basically be able to say is I have data with a unicorn characteristic, and that when I call save unicorn data, that it does this thing you want done.
Sure, that's fine. Right?
You form a unicorn queue for anything coming.
I want fsync. Really all I want is is distributed flush, and that's not trivial to implement. I mean, it's a well-known technique, but we do need to actually go build it. But I think that
what I'm getting a sense of here, in terms of generalized abstractions, is that we want to be able to mark certain data as having a characteristic, right? And we can argue about which characteristics.
That's a weird. I'm not sure that I necessarily agree that that's the right way to represent it, but it's a.
Well, let's dig into it for a second.
I'm just coming back because I'm missing some things in this dialogue. Where do we have unique and where do we have replicated? I'm not sure what you mean. Because replicated to me means it exists everywhere in our stuff.
Okay, so what I meant, what I think,
You might have meant redundant.
what I meant by replicated, which I think is what Colin meant by replicated, is that this data is accessible to any node in the cluster, and that if we lose a node in the cluster, that we continue to have this data. Is that more or less what you're thinking when you say replicated?
I mean, replicated to me means a majority of the nodes in the cluster know about it.
Yeah, I mean, everyone can know
No
that.
single point
It's more a
of
question
failure?
of where it's stored.
Or what is your definition of
For instance,
replicated?
my house's piece of information, I'm...
Does replicated mean
Right.
do
Wait,
failure?
Right
my
now.
piece of information, I will replicate once, so that I know I will have it if something falls over. Configuration information, I will replicate across the cluster, so that it's available on demand wherever, and I don't maintain a consistency.
Well, right now we don't have a notion of partial replication. So basically we implicitly replicate everything to all instances. If you wanted to change that idea, we can certainly have that conversation. I'm not sure how useful it is. I mean, it can...
In a sense, you really come back to, and Colin can push me in the direction he likes better, but you've really come back to my notion that you need to give some indication that there is some characteristic or set of characteristics of the data you're persisting, and that there may be some semantics around that.
At least so, I'm sorry. Never mind. Go ahead, sorry.
Right. So, for example, if your data happens to be unicorn data that needs to be universally distributed, right? That's a set of characteristics for your data persistence. It means that when I call the same unicorn data API, that will be subject to those semantics, etc. And I think we need to strive to keep the smallest, simplest set of characteristics we possibly can. But by doing it in that manner, number one, we give ourselves an easily extendable API for dealing with it, because you can define new characteristics and teach the proxy on them. Number two, you have a map that leads to models in the same way, because you can model the characteristics as metadata of the model that you want for a particular set of data, without putting Colin in a place where he feels like he's trapped by the model. Because even though I totally disagree with you about the probability of success of the model, I do agree with you about not feeling trapped. So while I'm of the opinion that one could clean up this notion of characteristics, it's sort of the ugly off the top of the head hack. It strikes me as being a fruitful direction to investigate.
I think that's about right, which is, right, which is when you open a file, you either open it read, or you open it, read write, or you open it write, or you open it, append, or this is not a new idea. The idea that when you create a data structure that you're going to go use, you would specify some salient properties of it before you start using it. I think that's right. I wouldn't. That's fine. And for now, we have one set of those characteristics, and we know we need at least two.
Right.
And so we might as well.
There's the property of that object.
And so
all of those.
In the notion of clustering services right now, what I would say is there's a create cache call. When you call the create cache, you pass it a name, and you pass it, and instead you would pass it a name and a set of configuration, essentially a set of configuration properties of it, which are characteristics, which we could add this terminology. Pass it something that said this one should be created as a persistent one, this consistently persistible one, which means that basically, and you also need a save function. And so when you call save on that, it does the right thing.
It's a cache log.
Yeah, it's per key value. It's per cache. The cache is a key value store, so you can use it. So you can store. You can have a config cache, and the config cache would store things like here are the list of all the subnets I have here, and then you could.
This is a relatively minor change to cluster services API-wise. You continue to have the original calls with some appropriate default.
Yes.
And default set characteristics.
Yes.
And you have an extensible way of being able to do all kinds of funky, stupid shit if that turns out to be reasonable.
Yes.
You could even manage to nest these into the proxy by saying that under if you want to contribute something that has interesting characteristics, then you need to come in with something that plugs into the data store proxy that gives you those characteristics.
Furthermore, I just eliminated your configuration interface, because now when you call config, you just have the cluster.
Or at least you made the config interface just a sugar candy.
A tiny, just a call to the cluster.
Tiny piece of sugar candy.
Yeah. So this is, but that makes sense.
So we write things down to see if we're actually
I was going to be variable. Okay, so basically like key values, that's the only way to query those caches.
In the long run, I would like to change that. In the short run, I think key value is probably sufficient. I don't know. Do you just disagree?
I know that our guys were saying it's insufficient fairly quickly.
Do they have a concrete example?
Well, what about
Actually, any kind of storages that are hierarchical in matter, even network configuration. Let's say that if you have network configuration, they say, okay, let's say I have configuration per port, per node, per port, per subport, per whatever it is, and you need to search all of them. You can flatten everything in one big data store and say, I search that big data store by one big key. I create a huge key, but it's totally not realistic. It's not practical. No, you will need to create, or you create multiple small ones that each one is key searchable, and then you kind of logically connect between them. How they do, and that if one fails, one port fails, you need to make sure that you fail all the chain.
So we need to look at that, right? Because we need to look at that. But I think that even in the case where you have something that is somewhat different in terms of the access characteristics of the data, that what we're talking about in terms of characteristics, still, if I need data that's handled in a uniform fashion, I still need data that's handled in a uniform fashion, right?
Well, I mean, I think there's two questions. One of them is about, there's one about persistence and sort of durability, and there's another which is about, we invented SQL databases for a reason.
There is a reason.
Difficulty with the queries.
Yeah. No, I mean, but yes, but there is likely to be data in our. There's likely to be data in our systems that want schemas. Some of those schemas are likely to be SQL schemas. Some of those schemas are likely to be other kind of schemas. But I think that it is true that key value stores are not the be-all and end-all of data stores.
I'm just saying that at least what I heard from our guys, that even for the first release, it is very limited.
If you just need exact match type of thing, you don't need sort of range walks or queries across it because they're going to pay for those. Then you can get away with a simple key value store. But once you start
by flattening everything out, you can get away with it. But it's non-realistic because it's a hugely sparse database with big keys and pretty expensive searches.
So the deal is, right, you don't put it all into one of these tables, right? You look up objects in this table that will then be able to, you can locate that object and then look something up in its hosted table, things like that. Right?
It's very expensive.
Well, no, you pay for the
extremely expensive.
You pay it when you need it, right? You pay it when you need it, and if you need it, you need it, right?
Well, I think
that just doesn't work.
That's the basis of all of our software today. This is how we do things.
Yeah.
Right?
So let me back up for a second, because I'm going to flog concrete, actionable, and putting actions on people, right? Which is, I think we have determined something that is concrete and actionable that we feel good about, right? Which is this very, very simple characteristics model, right? Simple, extensible, modular. You can imagine, people contributing characteristics independently. So, what is the concrete actionable thing that comes out of this, and who's going to determine it?
Clustering services needs to be augmented. The concrete thing is you need to augment clustering services to take attributes, characteristics, or whatever you want to call them. You need to modify. You need to add some kind of extra API call, which is saved effectively to clustering services. It's a no-op for most things, but is a positive op for one characteristic we have. We implement the one characteristic, and then we actually need to build something that goes out and asks everybody to write to disk and doesn't tell it to say yes until half the people have written. And you also need to make sure that it doesn't, it has a timeout, and when it stops, it lets you keep going, and cleans itself up correctly. And all of that is somewhat, and so the last part, the first parts are all relatively easy, the last part is really hairy.
Let me ask a question around save, because most people, so how often and by whom do we anticipate save being called?
I'll give you an example. And by the way, I need to bring up this point if possible. I would like an async save as well. So I want a lazy sync type of save.
Well, but you would like to know when it finished.
Yeah.
You effectively would like a save that gives you a future, so you can ask if it's done, and if you so desire, you can block on it being done.
Precisely. So
but the issue that I have with async save, and the reason why it is that I didn't bring it up, is that save sort of implicitly has to make sure that it saves at a point in time, which essentially either involves implementing copy on write, which I guess you could do, or implementing a block. And so if you're going to block anyway, you might as well block it to return.
So the way that we do, I think we talked about this a little bit last time. In our boxes, to get scalability, we have some very interesting requirements and usages of this database stuff, so I should have jumped in a little bit sooner. We highly rely upon partial replication stuff. We can't afford to replicate anything everywhere except perhaps config, right? We can afford to replicate some things to one other location or a small number of other locations, right? If you want to replicate everything everywhere, you get the scalability of one blade or one system, right? So two, yeah, it depends on how you, or half. It depends. It could be if you're
it's no better. It's strictly less than 2.
So because of that, our typical way to go forward is it's all we can't use non-volatile for storage for any of this dynamically relearnable data, but we will ensure that it's replicated to a physically separate piece of hardware before we enter into certain actions that sort of commit ourselves to the user. So for example, if we're about to send an accounting record, we have to make sure to synchronize the data to another blade before we can actually send off the accounting record, because at that point in time, it's externally visible that we believe that something was true. If we lose that state, then our box is going to do the work.
Yeah. So, but the thing is, I think what you're really wanting in terms of asynchronous save is not something that screw up columnist desire to have strict causality. What you're wanting to say is, I told you to save, I'm not going to wait for you to save. I'm going to go do other stuff. Like, I didn't want to know when you save.
Yes, so I want save, blocking save for quasi-transactional stuff and non-blocking save, and just as a feature that works out fine. But I also want to be able to specify partial replication. And I can give you a nice metaphor for how to do all that.
No, I understand it. What I'm saying basically is that becomes a characteristic of the data.
Correct.
Which basically tells me that basically having a characteristic model where effectively you can pass in a list of characteristics for the data, that becomes potentially a way to begin addressing this. And then just picking reasonably good defaults. That gives you something. That actually does bring me right to the question about when, how often, and who you think is going to call save.
At least for right now, it's for what I've been thinking about. It's literally user configuration data, which is that users are configuring OpenDub groups, and users are configuring policy between OpenDub groups.
I do not recognize the distinction between users and applications.
I get what you're saying, but usually there is a user somewhere down the chain somewhere.
So everything is a user, right? If there weren't users, then a perfectly correct thing to do would be to just write everything to dev null, because there's no users to observe anything, so it's fine. So there is a user who is actually entering something, and that something might be small, which is a seed to a program, which creates something larger, but there is some user
We don't always have access to that user. So that user is somebody who comes in to web API, the provider is put in front of OpenStack, makes a call to us.
I don't think Colin's saying we need access to the user. I think what Colin's saying is the user needs to be able to trust us.
There is some point at which the user, that we make a promise to an externally visible promise to somebody saying, this is a true statement, and we better damn well make sure that's a true statement.
That I completely agree with, and the only point I'm making is that external entity is going to be an application often, not just a human being.
It can be whatever.
The application could ask for the promise too. That's fine. I mean, we're gonna have.
And the reason I'm really pedantic about this, I'm sorry to be really pedantic about this, is I have seen so much stupid shit done because someone used the word user, and that put people unconsciously into the timescales of human beings.
Are you really talking about you want to distinguish an interactive session on a CLI or something like that versus an application?
All I want to say is there is some application which may have a person directly behind it or not. I don't give a shit. Right. And when we promise that application is something that's been done, that thing has damn well been done. And honestly, in my opinion, it's not even particularly about. It's almost more of a commit than a save, because it's not even just about the issue of have I saved the config data. If I've come in and asked you to do a bunch of stuff about provisioning my network, and I've told you that I've done it, it damn well should be done.
And And you know, it's a lot more, I mean, if it's not a human being, right, it's a lot more rigorous what our requirements are going to be, because, you know, the human is still taking a few milliseconds to type each letter or something like that, and so it probably covers a multitude of race condition sins at the moment.
Oh yeah.
Right? But if you imagine you have...
Speed makes all race conditions awful.
That's right. Slow typing means that we have fewer apparent bugs, right? But like, if you have a netconf interface, like let's say there's an application that's opening 2 netconf sessions.
Yes.
And a change in this session has to be reflected in this session. And the application logic expects that, which is reasonable if it does a commit, right? Well, and it doesn't actually happen, but we're talking, instead of keystroke time, we're talking a few memory access times, something like that.
Right, and I guess the point I'm making is, what are characteristics that we're dealing with some of this stuff? It's not just the saving of config.
Yeah.
It's if I come in and I say, I need these 16 flows provision for my application, and you come back and say, and I say commit, and you come back from that commit, you damn well better have those flows in place.
So you're saying you need a transactional type of guarantee, or at least a quasi-transactional guarantee, something akin to that.
I'm a little bit concerned though that we've wanted a little bit of fielding and dragged Colin's causal consistency back into the world of transactional consistency, and if I'm going to, and I don't want to do that too cavalierly. I'm not going to do it stealthily if I'm going to do it.
I don't think that's actually. I think the issue right now that we have is just that, you know. So the answer is I don't know how often people are going to want to call save. We're going to implement save. It's going to have a certain speed. And in the short run, you know, in the long run, we're going to have to deal with that. But in the short run, I don't think that we know. I don't think I can posit anything. But I know that we need the functionality. I know that we need to implement it. And it's going to be up to application writers to figure out how to get the properties they need to get out of it.
The way I see it is take the worst case. You're going to have the ability to save, and something's going to be telling the system to do stuff. And it may have a method where it says do something and save it, so that I know that you've really done it.
Yeah.
And it's going to send you 10,000 of these within a 5-second period. I mean, you never know. I mean, this is the.
And if it happens, you're going to joke. And there's nothing for it, but you've got to do it.
I think though that there's a deep conversation here. There's a shallow conversation. And the shallow conversation is pretty easy, right? The shallow conversation is that we need some capacity to indicate characteristics of the data that's being stored. And the deep conversation is to argue over what those characteristics should be, what their semantics should be, and how we should implement them. Right? So I think we agree on the shallow conversation, and I'm searching for someone to take some concrete action on it.
We maybe even. So just someone introduce this onto the mail list, and we can all contribute our ideas for these sorts of characteristics.
That's something, but I would really like to see code.
About the document or something.
Documents are not code.
They often save you from throwing away a lot of code.
I wrote an RFC. Isn't that enough?
Does it matter what language we're writing?
Yes.
If you write document in Yang, that's good.
I suppose you read the document in French. The Canadians will be fine.
I mean, I'm willing to try and wrangle people around this. If it ends up being me writing the code, I don't know what's going to happen.
I'm not even asking for a large amount of code, right?
I can take on the responsibility of trying to modify clustering services such that it can take characteristics and that you can add a save.
It can take characteristics and take some default characteristics. Maybe the only characteristic we have is sort of basically the null characteristic at this point.
Yeah.
But then we've got something that we can move forward from. Then we've got something we can bitch about and complain about, and people can send patches against, et cetera, right?
I can certainly do that.
You know, okay, cool, excellent. Is there anyone else who would like to take on something like that?
I would like to offer that we would, and I've offered that we would help with the infrastructure pieces, and yes, we do still have an interest, but ramping. But yeah, definitely I can voice an intent. How does that sound? And then get an ice cream.
That's not ice cream.
There are ice cream bars, folks, at some point.
Alex just sort of wandered back with ice cream. On purpose. An evil trick. I think that the discussion got too hot.
Couldn't take it anymore.
and you did a little cold.
I do want to say that there is a lot of really hairy sort of consistency stuff that we are currently not really addressing. And I think that I mostly understand it well enough to understand how it's likely to bite us, and that we can ignore it for a short period of time without it really killing us, but it's coming.
I just don't understand why anything about this is unique to ODP and should cause us to invent all kinds of stuff. Shouldn't all this be in kind of a solved problem?
I would imagine that quite a lot of it is a solved problem. It's just a matter of grabbing the right solution.
A lot of it's the added thing, which is somewhat frustrating, which is that a lot of it is a solved problem that's painful to stand up, which is a lot of it's a third-party tool. And so if you take the axiom that you really want this thing to, come down and work, that gets...
use every cool tool in the universe works against the stand-up easily.
I mean, I don't have any objection to somebody who says...
I would like to run Cassandra.
Who says, I would like to run Cassandra, or we need a charger. Or I would like to run Cassandra, or says that I think Cassandra is stupid, I want to run MongoDB.
We have one.
Okay. Yeah, or something like that. I have no problem with something like that complicating their life. I think that's awesome that they can do that. But I don't think Joe Blow, who downloads the controller, should continue to be able to download it, run.sh, and have a working controller.
Yeah.
With no persistence.
No.
Yeah, I
think there are ways we can actually do persistence.
Clearly,
Java. If you want to do, if that's actually your model, and you could say that you get persistence without clustering.
No, that's
or you get persistence with clustering if you stand something external to log. But that's, I don't know that I agree with that statement, but based on what you said, that would be a valid thing to do.
And it's probably internally consistent. The person that is going to create 3 million configs per second is probably operating on a scale where standing up a database as part of their infrastructure is not out of the question. The guy that wants to download the thing and type run.sh is probably pretty happy if you can't save more than 5 things an hour.
Where the guy who is working with the guy who's going to stand up 3 million stuff is just poking.
And
he'd like to download, poke, and run. He doesn't want to have to spend all frigging day.
Yeah, but it's just not clear that you can test drive everything at scale if your goal is to do a 20-second test drive.
Yeah, I mean, there are obviously going to be some issues about scale, just in the very simple sense that, for example, even if you were to embed Cassandra, so that every controller node is a Cassandra node, you can make some default assumptions about where you're going to put your storage. But if you're storing a shit ton of stuff, you should probably configure your storage to point to someplace where you have a shit ton of storage.
Yes, but I think that's the answer to your question, which is is there something which does this? I think the answer is there is. It's typically referred to as a relational database.
At least come very close to inventing the relational database several times here today.
If that's what you want to do.
But sort of as a matter of fact, we've decided that probably we don't want to require people to have to know how to stand up a relational database in order to run this. And I think I don't think anybody here would disagree with that as a generally good idea.
Yeah, they need to know much more than that in order to get our database working. Their qualifications are too low.
But I think that there's so I don't know. Anyway, that's the answer to that. It's a good question. I think JGroups. I was weird. I don't know where JGroups fits in this.
It's sort of rolled into it for this guy.
So I think JGroups might actually provide, if it doesn't provide this, might actually be low enough level that at least its consistency model is understandable, and you could build on top of that or build this, which would at least be sane. But I would have to go look at it. And I think even Infinispan does, in theory, support some mode where you can say this is durable. I don't know how it works.
Infinispan has cache stores that you can plug in. So you can basically say, this is how I would like you to deal with persisting the cache and loading the cache.
Yeah, and if you surf around, here's how you do it with NoSQL, and here's how you do it with SQL and Cassandra and Mongo. There's tons of examples of how to backstore it onto
they've got basically the modules for backstoring on stuff, and if you really want to go, if there's not a MongoDB module and you want a MongoDB module, you can go write a MongoDB module.
And so the problem is that it really doesn't provide the notion of complex consistency, which you really do want.
I understand that.
That was actually a question.
I don't know. I thought
that was not actually not a statement.
You need to make a question.
I need to learn how to talk about authority. I try to admit when I don't know what I'm talking about.
It doesn't really matter. If you use the appropriate tone, people don't believe you.
That's. But I think what you do need is I can take on the thing of trying to get at least the stub APIs at the top ready so that way you could plug something in that would do the right thing. I mean, if somebody has played around with this stuff and has some idea of how to do the right thing in Java, that would be great. I certainly have.
And I would just say like a nice patch that
made this possible.
That makes this possible from an API point of view, because that gives us a place for people to have a conversation against.
I'll put that
as concrete.
Without
digging so deep, we've done a lot of work to discover that like there are all kinds of reasons that people object to it.
Yeah, that makes sense.
Give it early, give it often.
I try.
I appreciate it.
Okay, I think that makes sense. I think at least there's now 12 of us that understand the issues, and that's a whole hell of a lot better place than we were before this.
So
this should.
If you're looking for non-code things to do, Chris or Jonathan, I mean, summarizing this conversation with mailing list would probably be very productive.
Jim Gray did actually ask me something like, there was all of this mumbling about consistency, and then it died. And I was like, funny that. We can certainly play around with this.
The question is, can we retrieve any consistency?
I missed so much of the beginning of this one. I mean, I would substitute so much of my own opinions into.
Now you understand the value of volunteerism.
Colin said that Eric's way of doing database is absolutely the best one, and Ed agreed.
I can provide my failing editorial skills.
You took excellent minutes this year.
Yeah, and then I found it that's why I said flavor.
And will those nodes be consistent?
They will be. With my but not
This is the really easy way to make things consistent, which is you have one person over them all.
But will it be consistent with other people?
I don't know. I want ice cream.
Ice cream. All right.
Hackathon, literally.
Really? Yeah, that just did.